This is Unit 1, Lesson 1 of Common Core Algebra 2. The lesson title is Variables, Terms, and Expressions. If you take a moment and read through the paragraph at the beginning, you'll get an idea of where we're going with this lesson. Anytime during this video, if you need more time, or you want to rewind, or maybe fast forward, you know that you can do that on your particular device. Because this is the first video that we are using for our new course, I am going to be giving you some pointers to be a successful note taker from a video. I apologize if it's boring for some of you that might already know how to do that. So let's begin. We're going to start with some basic definitions. I'm not going to read through the definitions, but I expect that you will copy these down into your notebook. So you want to go ahead and pause and write the notes down in your notebook to be checked by your teacher. Let's start exercise 1. Consider the expression 2x squared plus 3x minus 7. How many terms does this expression contain? I'm going to go ahead and underline each term. From the definitions above, a term is a single number or combination of numbers and variables using exclusively multiplication or division. So looking at my first example, we have 2x squared, 3x, and negative 7. So that would be 3 terms. Part B. Evaluate this expression without your calculator. When x equals negative 3, show your calculations. In other words, we're going to substitute negative 3 in place of x. It would look like this. So we're going to start calculating. 2 times negative 3 squared is 2 times 9 plus 3 times negative 3. And my writing will get better as I practice more. This multiplied gives me 18. This multiplied gives me 9, negative 9, minus 7. And then I combine all of those and I get 2 as my answer. Part B. What is the sum of this expression with the expression 5x squared minus 12x plus 2? Well, I'm going to go ahead and write them next to each other. And then I'm going to underline my like terms and combine those. And there's my answer. You will want to copy the examples down and possibly my work if you feel that you need it for future reference. Like terms. Please copy the definition of like terms into your notebook. Exercise 2. Most students learn that to add two like terms, they multiply, add the coefficients, and leave the variables and powers unchanged. But why does this work? Below is an example of the technical steps to combine two like terms. What real number property justifies the first step? Well, let's take a look. We start out with 4x squared y plus 6x squared y. And then we rewrite it with the x squared y on the outside and just the 4 and 6 in a parenthesis. So what property did I sort of undo there to take out the x squared y from each term? If I notice, each of these individual terms had that x squared y. So I factored it out, and I added the numerical coefficients. That is the distributive property. Okay, moving right along. Let's do a little review of our real number properties. Again, I would take this time to pause the video and copy these properties into your notebook. Once you have copied them, you can go ahead and start the video again. Exercise 3. The procedure for simplifying the linear expression 8 times a quantity 2x plus 3 plus 5 times a quantity 3x plus 1 is shown below. State the real number property that justifies each step. So in our notebook we have all the properties. We're going to be comparing from the property definition to the process that are outlined in exercise 3. So I'm going to move my worksheet up so that I can do some work. You will be referencing your notebook definitions that you copied down. So in our first step we have 8 times a quantity 2x plus 3 plus 5 times a quantity 3x minus 1 equals, and let's see what changed. 8 times 2x plus 8 times 3 plus 5 times 3x plus 5 times 1. It looks like each 8 and 5 were distributed into the parentheses, so that would be our distributive property. In our second line, what is different? We have 8 times 2x plus 24 plus 5 times 3x plus 5. It appears that there are parentheses. And when there are parentheses, that means things have been grouped. And when we think of grouping, we think of our associative property. So this is associative property of multiplication. That was kind of messy, but it says multiplication. In the third step, let's look at what we have. 16x plus 15x plus 24 plus 5. If I look at the previous step right here, comparing that one with this one, it looks like there was a change in the order of the terms. When there's a change in the order, that is the commutative property. So this step is representing commutative of addition. Comparing that step to the next step, it looks like what's changed is this little x sitting out here. And it looks like the x has been taken out from or divided from the 16x and the 15x. That would be our distributive property. And our second to last step, it looks like what's changed is the grouping has changed. So instead of it being grouped with 16 plus 15, we have a group with 24 plus 5. And a grouping change is our associative property. So again, we have associative property, but this time it's associative of addition. And in the last step, what we did is just combine the 24 and the 25 to get our final answer. And there is no property necessarily for that. This is our last exercise. Exercise 4. Because we use real number properties to transform the expression 8 times 2x plus 3 plus 5 times the quantity 3x plus 1 into a simpler form, 31x plus 29, these two expressions are equivalent. How can you test this equivalency? Show work for your test. So the easiest way to show equivalence would be to choose a number and plug it into both expressions and see if you get the same answer. So I'm going to make a note. Okay, so let's pick a number, and I just use x equals 1. And we're going to take our 8 times 2x plus 3 plus 5 times 3x plus 1 and plug in 1 for x. So wherever I see an x, I'm going to put a 1. And then I'll do the math and see what value I come out with. So 2 plus 3 is 5, and 3 times 1 plus 1, 3 times 4. So I get 40 plus 20 is 60. So if these are equivalent, when I plug in x equals 1 into the other expression, 3x plus 29, I'm going to make that a little bit neater, plus 29, 31 plus 29 is 60. So they came out exactly the same. I could test other values, but I feel confident that these two are equivalent. I could also use my calculator, and we will be learning how to do that later in the unit. And that's it for this video.